forming luster and forming a hard shell. So this is what forms the atom from our perspective. Okay, next slide. So maybe I didn't explain it really well, but the reverse uncertainty principle is something I've come up with. It's not even my theory. It's basically the Heisenberg theory in reverse. So the further into the future we attempt to predict the position of a celestial object in a star system, the more erroneous our predictions will become in relation to the actual position of the object due to unknown internal or external influences, compounded influences. Within this framework, a star system increases in velocity approaching C, for whatever reason. It becomes an atom, where the Heisenberg uncertainty principle describes the difficulty of determining the position of a quantum particle in an atom. The reverse uncertainty principle is, again, the Heisenberg uncertainty principle as perceived in a reverse perspective. So, okay. All right, I'm going to go on to describing a celestial charge, because we all know that quantum particles, especially electrons and protons, are positive and negative. And we know that gravity at our scale, at the macro scale, the cosmological scale, is always attractive. At least that's what theory says. If star systems and atoms are the same thing at two different points in the velocity spectrum, then what would constitute positive and negative charge at the celestial scale? The concept of positive and negative refer not to an isolated characteristic specific to a single particle, but are defined by how various particles interact with each other. It's all relative. Positive and negative refer to the action where the particles attract or repel each other. The label of positive and negative is a human invention to categorize particles in association to how they interact. There is no positive or negative. It's based on how they attract or repel each other based on the type of particle they have. So common properties between particles, and then you measure to see if they attract or repel each other. And this is the invention that we came up with for positive and negative. Okay, next slide, please. Oh, you were? Okay, sorry. So at the celestial scale, how do various celestial objects, or cosmological objects, interact? Do some attract while others repel? Currently, classic gravity theory states gravity only attracts, but gravity in the traditional sense alone does not completely define all attraction or repulsion behavior between cosmological objects. Stars and large gas giants are very hot, continuously expel heat in the form of particles and photons, which can exert a repelling force. That's right next to it. This obvious repelling force created by large celestial objects like stars and gas giants can exert a certain force per square area on other objects. If the area is small, like a rock planet versus gas giant, then the gas giant's expelled heat would not exert enough force to repel the rock planet over gravity force. I'm not explaining what gravity force is, I'm just saying it's an attractive force. There are other forces that would repel outside of just the definition of what we mean as gravity. If the area is big, like gas giant versus gas giant, then the expelled heat from both gas giants will exert enough force to overcome gravity and repel each other. This alone defines the type of celestial charge, but it's a bit more complicated. Celestial charge, as analyzed from the big picture perspective or topological perspectives, does have attraction and repulsion. In this framework, which I'll explain in a few minutes, similar objects, size and type, repel each other, while significantly different objects attract. The key is in relation to mass density. So this is just to represent that similar objects would repel objects of significant size and type would possibly attract. Next one. And there's a reason for that, and I'm going to go on to it. If expelled heat from large celestial objects can exert repelling force overcoming gravity, then what fully constitutes the definition of gravity? Does the full definition of gravity constitute this repelling force? Again, this repelling force is due to expelled energy from these planetoids. We don't classify that as gravity, but from a very large perspective, if you stand back and you just see how these planets interact, what do we define as gravity? Looking at the quantum realm concludes it's well known that charge can travel very large distances, charge force. This causes a problem for expelled heat repulsion because it would be strongest, very strong, at close distances, and diminishes greatly over large distances. Quantum charge appears to travel relatively indefinitely, distances only diminishing depending on the medium and what it encounters. The medium being ether, possibly. Gravity and wave theory, sorry, next week. and this is where I put them all together. Gravity and wave theory, in my perspective, are completely mirrored. Gravity force travels at the speed of light. This is what we assume. This is what modern-day science says. Then light, full spectrum, is what causes gravity, because we don't know anything else that travels at the speed of light. Light travels indefinitely unless impeded. Light has wave properties, therefore gravity must also adhere to wave properties. In part, to wave properties, to wave theory, sorry. The full spectrum of expelled energy from a planet, manifesting as slow heat, magnetic fields, particles, photons, other quanta at all scales, remember this is a scaling theory, all scales and velocities, collectively constitute the effect of gravity topologically and all adhere to wave theory. Wave theory, to me, is the key to all of physics. Next screen. In wave theory, constructive interference of all emitted energy, this is a topological view. Energy does not expel in this fashion. But if you were to see those, the expelled waves as energy forms, then you would see that it falls to wave theory. So wave theory, in wave theory, constructive interference of all emitted energy would result in attraction within this framework. The first half of this shot there shows you that two different waves will become constructive, and therefore they would be attractive. Destructive interference of all emitted energy would constitute repulsion. So, as you see the bottom screen, if two planets emitting the exact same type of energy would interact, they would, in wave theory, become totally destructive. And totally destructive in this theory is repulsive. So this means that the similarity and size of composition of wave energy sources, planetoids, asteroids, matter, is very important. Similar sources repel while significantly different sources attract. Next screen. Now, this is where it gets complicated, because I bet you some people are saying similar objects should be repelling each other, therefore why aren't the gas giants flinging out into space? Wave theory is simple depending on its scope, but it gets complex when you have more wave emitting sources that are added. For example, all three objects here are identical. There's identical in shape, size, and type, and composition. Red and green are beside each other. The interaction between the two of them is destructive, completely destructive. So they're, in theory, they're repelling each other. But they're also emitting their energy out towards blue, and blue is further away, and the wave construction between those two, based on the angle, is actually going to be a constructive wave pattern. So even though red and blue are repelling each other, they're actually together attracting blue. And that's the wonderful thing about wave theory. So next screen. So I went on and I had to put this into an equation of some sort. The equation is basically very simple. It takes the mass density of the objects, two objects. I haven't gone any further than that. And essentially, if the two objects are identical, it produces a negative one. So the charge component is negative one. If the two objects are significantly different, it would produce a positive one. So repulsion, attraction. And that's part of a gravity equation that I put together, which is right down there. So in conclusion to all this research and work, this is what I've been working on over the last few years, part-time, is to get to this point where I can actually calculate force at the cosmological scale being equal to electric force. And we've always seen this in textbooks. We have F equals ma, mass acceleration, and we have F equals Q, QE, which is charge times electric field. Within this framework, mass and charge are the exact same thing at two different points in the velocity spectrum. We're talking about low velocities and extremely fast velocities near the speed of light or beyond the speed of light. So that says that mass and charge are the same, and it leaves acceleration being equal to E in the electric field. In my assumption, the electric field is an acceleration field based on that relationship. Same thing goes for Newton and Coulomb's laws there. M1 and M2 become Q1 and Q2. Distance squared is invariant, they're the same, because the distance between objects within this framework is invariant.